Saxon Algebra 2, Lesson 72. We have a two-parter today. And the first one is a little bit of a breakthrough in our experimental data problems. Let me show you what we're dealing with here. Okay, so you know you have your friend who's a scientist and he's been working in a lab and he's been doing these experiments and we've been trying to help him do the math, right? And what we've been doing is helping him write equations of a line that describes the relationship between whatever he's starting his experiment with and whatever he's ending his experiment with, right? And we've been helping him write these equations, and it's kind of hard because he's been drawing lines, like down here. He's been drawing the lines that connect the data. And we don't always like his lines. They don't cross the corners of the graph paper neatly, and so it's really hard to find pairs of points that we need for our calculations. So here's the good news. We've convinced him to stop drawing the lines. Let us draw the lines, we told him. Let me draw the lines, you told him. I can do it better than you, no offense. So now he's gonna start giving us his lab books with just the different experimental data results, right? When he put in this much carbon, he got out this much, what is it? Salt, right? He's just showing us the results of his experiments here, and we get to draw the lines. Yay. But the problem is with great power comes great responsibility. And it's not always easy to draw the lines well. And John illustrates this for us, that given this same set of data points, you could draw the line following these points more closely and say, these guys are weirdos. Or you could draw the line this way and say, yeah, these are the better results. These guys are weirdos. I personally would argue that the line should go through the middle of all those points, right? Showing respect to both of them, to both sets of them. I would draw the line where it goes right through the middle. Here's the thing. You get to decide, okay? You are running this calculation now, and you get to draw the line. My best and only advice to you is make sure that you begin and end your lines exactly at the corners of the, quote unquote graph paper at perfect points on this chart so that you can easily read two sets of points and do your calculations accordingly, right? You draw the line so that it begins and ends at what we would call perfect points, right? That will allow you to quickly grab those two values and use them for your calculations. So that is my tip for you. Okay, so once you do that, you'll draw your line so that it begins and ends right at the corners of the graph paper is what I mean by perfect points, right? It's easy to read the value for that particular point on the line. Then you'll use those points for your calculations. It will be a very low point and a very high point, but that's okay. They'll work out just fine. So the 2 points you choose will be x1, y1, and x2, y2. Then you'll use those for the calculations, just like we have. Right? First you'll find the slope, and then you'll use the m and 1 point to solve for b. Using good old y equals mx plus b, right? You'll have values for those three. So the first step is to solve for m. And the second step is to use this value for m and one of your pairs of points to solve for b. You now have control over these points, right? You get to draw them. I would literally grab a ruler and a pencil and have a good eraser on standby and draw the points. Like I would make it start right here at 40, 0. I would make it start right there and I would make it come out so that it ends right at that point, which is what? 160 and 10. Okay, so choose your beginning and ending point so that you'll be able to read them perfectly. Then whatever happens in the middle, who cares? You don't need those points. You've got your 2 points, and then you can do your calculation just as you have been doing from there. Literally write that line in your book, and then erase it when you're done so that you can see your own line and you're not relying on your friend's sketchy lines that don't meet at the corners, okay? Now, that's the glory of these problems, is you get to draw your own line. The problem is that John's line is probably not going to be exactly the same as yours. So his slope is going to be slightly different, and his value for b, his y-intercept, will be slightly different. Compare your answers to him and see if you're in the same neighborhood. Now, I understand that involves a lot of judgment. So here's the thing, if you're not sure if you're getting these problems close enough, if this all just confuses you and is horribly vague, talk to me, all right? Either in your video chat or send me an email or text me, reach out to me and say, yeah, what? And I will do some more explaining, all right? But if you're understanding these problems at all, you can see the power of saying, ooh, I get to draw my own line now so that I get to choose what the 4 points or the 2 points will be, the 4 different values. All right, with that power comes a lot of the old stress goes away, but your answers aren't gonna match John's. They should be close, but that's the next annoying thing. So I'm sorry, these problems are the total bugaboo of Algebra 2, but they're worth doing because these kind of problems come up on standardized tests quite often, and it's great that you have experience. Okay, enough about this. We're going to change gears now and talk about something that's much easier to understand. Negative angles. Now, negative angles are not angles with bad attitudes. They're just angles that are measured from a different perspective. Now, so we're talking about trig. Let me explain. Normally, when we measure our angles, say we have a polar coordinate that looks like this, okay? We know this is the angle, this is the hypotenuse. This we measure first from here. We start here and we go this way. Each quadrant is 90 degrees, right? So we add as we go. And we can see we're gonna need 90. We're gonna need the whole next quadrant, which is another 90, that's 180. We need to go to 210, so we need another 30 from this quadrant, right? And we would draw our angle like that. Because now when we go the whole way around to our angle, that is the 210 degrees. And then we say from here to our point, we just say, oh, look, it's 4, right? We don't have to measure or be specific. When we measure the angle, we have to be very precise, counting through the 90-degree quadrants to get to the total of what we want. Oh, no, that's right, 180, 210. But the hypotenuse measurement, we can just call it whatever we want. It's no big deal, all right? That's the way we do positive angles. We start over here and we go up. But what if it's a negative angle? What if the polar coordinate we received is minus 220, or 210, sorry. We simply are going to go in the opposite direction. We're gonna measure the same way, but going in this direction instead of this direction. So we have the same rule. Each one of these is worth 90, right? So we're gonna count the same way. We're gonna need all of this one 90, all of this one 180, then we're gonna need another 30 here. This will be 30. Then this whole thing, that will be 210 degrees, and then we'll make our hypotenuse be 4 just because that's what it says, right? The hypotenuse, we don't have to measure that accurately. We just call it what we want. Okay, so when we have a negative angle, I don't know if this is going to help. Negative angles are measured in the opposite direction. Those words don't help me at all. This is what helps me, is just seeing the picture. All right? So this is just another way that John can send us a treasure map, right? He's sending us a treasure map to this point. He could have said, look, he could have said from here to here, how many degrees is that? Well, let's see, it would be this 90, plus it would be another, this is 30, so we'd need another 60. It would be 150 degrees, right? 90 plus another 60 to get to this 30-degree angle. He could have written this as 4 times positive 150 degrees, right? That would get us to the very same place. It doesn't matter. You can write it either way you want, right? We have options here. We can write it as a positive number or a negative number. And that really depends on other parts of the problem, all right? Notice that the positive angle and the negative angle add up to 360. That will always be the truth, because wherever our angle is, measuring it positive or negative will create the whole circle. Do you see what I mean? So the 2 will always, ignoring the minus, the 2 will always add up to 360. Okay, so when we get a negative angle, like this one, we draw it, we create the triangle, and then we solve just like otherwise. John wants us to write it in rectangular coordinates. Okay, fine. So all we have to do is just use this to come up with our triangle here, and we know that the right value will equal 4, the hypotenuse, times the cosine of 30 degrees, and the up value, right, because we're changing this into rectangular coordinates, the up value equals 4, the hypotenuse, times the sine of 30 degrees. We've done enough problems now that we know this is the pattern it's always going to create. Cosine is related to adjacent over hypotenuse. Sine is related to opposite over hypotenuse. The adjacent is the right. I'm saying words, you're probably not even following them. But we've done this calculation enough times that we don't have to write it out in terms of the trig functions. We can jump right to this. We go to our calculators. We get 3.46 for that value, and we get 2 for that value. Again, the way we enter these in the calculator is 30 degrees cosine times 4 equals 30 degrees sine times 4 equals. All right, and so now we can write this. We know there's a sine and a value for the right, and a sine and a value for the up. This is the way our answer is going to look. We know the numbers are 3.46 and 2 exactly. Let's think about our signs. The right value is actually a negative right, so we'll put a minus sign there. The up value is actually positive. Great. This is the final answer, and guess what? It is correct. Beautiful, right? If you are still struggling to figure out how I set these up, please reach out to me. Please ask me for more help. Okay, should we do another one? No, we don't get to do another one. That's it. Oh, I'm so sad. So now John's going to play around with us though. Sometimes he'll give us positive angles. Sometimes he'll give us negative angles. Remember, negative angles work the exact same. We just measure in the opposite direction. The end. Goodbye.